Hey everyone, in this video, we are going to talk about the transactional outbox pattern. You might have come across this term before, but in this video, you will exactly know when and why to use this pattern. By the way, if you're new here, my name is Daim, and here in this channel, I talk about everything from system design, software engineering, to building startups and side projects. Before we dive deep into the technical side of the problem, let's try to understand what is the problem that this transactional outbox pattern really solves. So consider this use case. Let's say you're asked to build a feature where we need to send a confirmation email to the user whenever an order is placed. So let's say you're working for Amazon or any e-commerce company like Zalando and stuff, and then you need to send a confirmation email whenever an order is placed. Seems straightforward, right? A reasonable feature. So consider how would you implement this, right? You will probably have like a backend service, like called an order service, right? Which will be connected to a database. And then whenever the user places an order, the order service adds a new row in the database in the orders table saying that a new order was placed with the status of confirmed, right? Once you have written that to the database about the new order, you can actually take that order ID and the order information and then call some sort of an email service like Mailjet, SendGrid, or any other service, email service, and send the email, right? So first you write to the database as step number one, and then step number two, you send an email by calling this third party service like MailChimp, SendGrid, and passing it all the order data. However, there's a problem here. Because we are in distributed system, right? That means that these calls are happening over the network. The database is probably some Aurora cluster that is located somewhere. So this database call can fail. Similarly, this API call to the send email can also fail, right? Maybe temporarily the network connection times out or whatever happens, right? So this call can also fail. So what happens when the failure happens, right? So the user placed the order, you write the order to the database and say that the order is confirmed. But when you try to make the API call to this email service like MailChimp or SendGrid, you get a failure, maybe the timeout, maybe some temporary network issues, right? Networks can be unreliable. How do you fix this, right? Because what happens in this case, like once this call, right, step number two to send mail fails, the confirmation email will never get sent because the user placed the order and you saved it to the database. But when you try to call the email service after saving to the database, it failed. And now that email was never sent. So even after the email service recovers or the mailjet service or the network issue recovers, you will not send the email, right? Because the order has already been written to the database. So that email was always lost. So now this is a problem, right? Because like in the case of e-commerce, like if I'm placing an order at Amazon, right, I would expect that I get a confirmation email. I paid the money. So I expect as a user experience that I get an email confirming my order, letting me know that it's on its way, so, right? Otherwise I will panic as a user. So how do you really solve this problem? So we need to kind of guarantee that, whenever an order is confirmed, the email should get sent at least once. So we need to have these at least once guarantee semantics. We need to ensure that whenever an order is placed, the user should always get a confirmation email. How do we do that? So consider this. One approach we can take is following, right? Whenever user places an order, right, we write two different rows to two different tables in the database. So the first row we write is to the orders table that the order was confirmed and save all the order details. But we also have another table in the database which we can call like email confirmation email table, and to that we also write email pending, right? And then these two things can be atomic because this whole thing is a single database operation. The database, we know, guarantees if you're using Postgres or any SQL database, it will give you this transactional guarantees like the asset properties. So you can enforce that this entire operation is atomic. That means for whatever reason, if the order confirm row fails to insert in the database, the email pending will also not get inserted, or vice versa. So if we fail due to whatever transient failure to store this email pending row to the email confirmation table, this will also be rolled back. So database already offers us this atomic DB rights. So the step one to solving this problem is to have two tables instead of one. The first table would be the orders table, the second would be email confirmation table, and then we do an atomic write where we save the order confirmed row and we save the email pending row. Okay, so once this has been written, then what we can do is have a separate cron job called order email confirmation cron job. And what it does is every 30 minutes, every 15 minutes, or every minute, like, whatever frequency you want, it polls the database, fetches all the pending emails that have not been sent, right? Pending. And then, like, for each of them, send the confirmation email. Once we receive a success response back from these email service that the email was indeed sent, we update that email status to sent. So that way, then the next time the cron job runs, we will not fetch the pending email for that order job, and, like, we send the email, right? So simple as that. Like, so once we have the pending rows in the database, this cron job, it fetches the pending emails from the database. For each of the pending email, it just sends the email to the user by calling the email service. And once this API call step number 2 is successful, we also mark this as step 3. So, right now, let's consider the failure modes in this, how our system will behave, because again, this is a distributed system, right? So we need to always think about failures, like how would the system behave if certain parts of the system fail, right? So failure mode 1 is like actually the call to MailChimp or this email service, right? Send great fails. What happens then? So let's say the cron job runs, it fetches all the emails that were pending, right? And it tries to, for those pending emails, it tries to send the email by calling the mailjet, right? But we either never receive a confirmation, or just, like, the email fails. We call the thing and we get a 500 and says no request, our request failed, right? What happens then? Well, because step 2 number failed, step 3 will never get executed. We will never mark this email as sent because we didn't receive a success response. And what happens is, like, when the next cron job runs again after 30 minutes, hopefully by that time this email service has recovered, and we should be able to, like, then send the email again and mark it as success, like in the step 1, right? So in case of a email service failure, our system remains consistent. The behavior of the system remains consistent. We don't get any data corruption. We don't get any undesired behavior. If the email service is failing, the cron job will just, like, wait, because, like, it failed, so it will not mark those emails not as sent. And after 30 minutes, after 1 hour, whenever this cron job runs again, hopefully by that time when this email service is recovered, we will get all the pending emails and send the emails to them. So that way we can guarantee that no matter whenever the email service fails, we will be able to send the emails always whenever the email service recovers back. So we can guarantee that the confirmation email of an order will always be sent, right? Even if the email service gets temporarily down, because this is a cron job, it will keep retrying, and once the email service is back, the moment we will send all the pending emails. So it will not be immediate, but it will eventually send it. So we will have some sort of eventual consistency, but we will always send the confirmation email, which is great. What happens if there's a different failure mode? So instead of, like, the email service failing, let's say the step number 3 fails, where we mark the email as sent. So the cron job runs, it fetches all the pending emails, right? And for that email, it calls the email service to send the email. Once we send the email, we receive a success response back from mailjet or sendgrid, right? So we know the email was sent. But the moment we were trying to mark this email as sent, the server crashed because somebody pulled the plug, or I don't know, anything can happen, right? The disk failed or whatever, right? So we have a failure at step number 3. What happens then? Well, in that case, when the next time the cron job runs, because we never marked this email as sent, we will fetch the same email again because it was still in pending, and resend the email again. And this time, hopefully, we don't get a failure at step 3 and we are able to mark the email as sent. This means that generally most of the time email will be only sent once, but on certain rare occasions, right, where there's some transient failure here in the database, there is a chance that a email can be sent more than once. A confirmation email can be sent more than once, right? This is why when we talk about transactional outbox pattern, we say, like, it guarantees, like, at least once semantic. So it says that we will send the email at least once. We guarantee that. It could be more than once, sometimes occasionally in case of failure, but we guarantee that email will at least be sent once. So this is the one in a nutshell, like the transactional outbox pattern, right? So you use this pattern wherever you have, like, a system right, that needs to kind of like call a third party, right? And you only want to call the third party, you want to guarantee call the third party whenever your local database operation passes. Like whenever you have this pattern, right, basically where you have a service and you are updating your database, and then you want to kind of guarantee that whenever something in your database is updated, you want something else to happen and you want guarantees for that. This is where you can use really the transactional outbox pattern. So for example, another example could be that instead of like this email, there could be an inventory service, right? So whenever an order is placed, we might need to call the inventory service to reduce the amount of stock in the inventory, right? Because somebody bought something from the inventory, right? So we can also use this pattern there as well, right? Where we say, okay, whenever our data, we place an order, we need to call the inventory service as a transactional outbox. So always whenever you see this pattern where you have a service, you're writing something to your own database, right? And after the database, after you have written something to the database, right, you want to guarantee that some third party service, right, that is over the network needs to execute some action. You can use this transactional outbox pattern, right? And whenever you want to guarantee at least once semantic, you can really use this pattern. So another thing, like you might ask, right, like why not like just, so it's obvious, right? So there could be a couple of things, right? Why, if we just like, we cannot put this in our transaction directly. Like somebody might be thinking, I know if you're a beginner, you might be thinking like, okay, just like a database, we have this atomic, right, these two operations. Why cannot we just make these two things atomic, right? Why cannot we just make the write to the database and the call to email service atomic? The reason we cannot make it atomic is like the database and email services are two distinct separate services, separately distributed on a different network, right? So the database would be in a AWS cluster, and email service could be hosted somewhere else totally, right? And these two both are divided over a network. That's why we cannot use like normal transaction. These are not the same machines. Email service and database are not on the same machine basically. So that's why we cannot guarantee like atomicity here, right? Because they're distributed over a system. On the other hand, we can guarantee atomic writes to the database, because writing to the two different tables to a database is straightforward. Why? Because the database guarantees it, because it is, the whole database is on a single machine, roughly, like just to oversimplify this. But like, yeah, so that's why we use, like we kind of exploit this feature of atomic writes to the database and combine it with a cron job to kind of guarantee at least one delivery. And this whole thing in a nutshell is basically known as the transactional outbox pattern. So I gave you the example with email, but this could really work with anything, like informing the inventory service to reduce the inventory, or literally anything. Like it could be like making a call to someone, right? Or any other service could be. So what are the limitations of this? Like everything, like in distributed systems, this also has a trade-off. Everything is a trade-off in software engineering and distributed systems, and in this case it's very obvious. So the first thing is that messages can be sent more than once. So the semantics for this transactional outbox pattern is like at least once delivery. The guarantee is like we will deliver at least once, but on rare occasions we can send duplicate emails, right? And the problem is like there is some complexity in the system that you have introduced right now, because you need some sort of a cron job here, right, to constantly run and send these pending emails, right? And then like with the introduction of this cron job, you need to kind of monitor that cron job. You need to ensure that it's running right, it doesn't crash. If it crashes, it restarts automatically, right? So you do introduce some complexity on a let's say on a infrastructure level, right? But it does help you avoid like more complex solutions like a two-phase commit, which is a distributed transaction, and it's like super complicated and slow, and mostly you should not use that. So yeah, this really these are one of the two limitations. Another limitation of this system is obviously eventual consistency. That means like the email wouldn't be immediately sent. So once the database is the row order is placed, there could be a chance that the email gets sent 30 minutes later, because the cron job is running at a frequency interval of 30 minutes, right? So you will eventually you're guaranteed to eventually get a confirmation email for your order, but like it will not be instantaneous, right? But eventual consistency is kind of like a feature of distributed systems, right? Because when in a distributed system, when failure happens, we really have a choice between availability and eventual consistency, right? So we would rather have eventual consistency and keep the system available. Yeah. So that's the third drawback. So the limitation is basically you have eventual consistency, messages can be sent more than once, and you need some sort of a cron job to kind of implement this. However, it's still a pretty decent solution and it works quite well. I have personally used it in my day job in multiple different places. And like these days, like you have pretty good tools to monitor and run cron jobs. There are nice frameworks that support that automatically. Yeah, so that's pretty much it. If you like the video or you disagree with something that I said, feel free to write that down in the comments. And if you want me to discuss anything else regarding distributed systems, feel free to let me know. I'm super happy to discuss more on that. And until next time, have a good one. Bye.